What we do is I have the cosine of theta x and the sine of theta equals y. We know that is true for every. So when I want the sine of 2 pi over 3, I go to 2 pi over 3, which is right here in my second quadrant, and I say this. I know this cosine value. This is the sine, and that's radical 3 over 2. And what is it? It's the distance from the x-axis up to the point. This is the x over to the left and then up, just like you would plot any point on the coordinate plane. So now cosine of 7 pi over 3. So I go to 7 pi over 6. 7 pi over 6, which is in the third quadrant. Let me move this up. And it asks me for the cosine. So I look at the values of 7 pi over the cosine value. This is the sine value. This is my tangent value. My tangents I really have to just memorize. But the cosine is negative radical 3 over 2. Tangent of pi over 3. So let's look at that. I'm going onto the first quadrant. 3. Now, pretend we didn't have this already evaluated. Let's work it out. We have the cosine and the sine. But have on the bottom of your unit circle, cosine, sine theta. Oops. How's that? Cosine theta, sine theta. Every x value is a cosine theta, every y is a sine theta, and the tan is the sine divided by the cosine, or the y value divided by the x value. So, for tangent of pi over 3, we're going to just do the math. We know that the cosine of pi over 3 is 1/2, and the sine is radical 3 over 2. So we're going to put the y value, radical 3 over 2, we multiply by the reciprocal. So cross that out, you're multiplying by the reciprocal of that, and you get radical 3. So the tangent of pi over 3 is radical 3. All right, now the secant. Okay, this is a reciprocal angle. Let's put our reciprocal pairs up at the top. Okay, we have the sine theta, the cosine of theta, and the tangent of theta. Those are our main trig functions. Now let's put we have the reciprocal of the sine is the cosecant of theta. The reciprocal of the cosine is the secant. The reciprocal of the tangent is the cotangent of theta. I want you to notice something in here. This might help you memorize these. Every pair has a cosecant, the cosine, the cotangent. Okay, so if ever you're wondering what's the reciprocal, it's one of the pair has a co. All right, so the secant is the reciprocal of the cosine. So with reciprocal functions, step 1, and let's just write this, reciprocal functions. Okay, what we're going to do is 1 will evaluate the reciprocal. Evaluate reciprocal function. So this problem right here, we're going to 7 pi over 4. And I'm looking at my unit circle, and I hope you circle, and I say, okay, the cosine of 7 pi over 4, oh, that's radical 2 over 2. Radical 2 over 2. That's step 1. Let's do step 2. Step 2 is flip it. Flip it and simplify. You'll see what I mean. Just flip it and simplify. Therefore, the secant of 7 pi over 4 equals, flip that, 2 over radical 2. What I mean by simplify is really, sometimes you get situations like this. I cannot have a radical on the bottom. That's like a math no-no. So I multiply the numerator and the denominator by radical 2 over 2. And I just multiply just a fraction, right? So I just multiply straight across. That becomes 2 radical 2. 2 times radical 2. Radical 2 times itself is just 2. And I can simplify this. The 2's will cancel, and my answer will be radical 2. Okay? Evaluate the reciprocal function, and then flip it. All right. Let's do a few more of those. The cotangent of pi over 6. Well, let's evaluate the tangent. The tangent of pi over 6 equals, well, look over at your tangent. You look over there and you say, okay, the y value is 1/2. And the x value is radical 3 over 2. I know that tangent equals sine over cosine, or y over x. Okay, that's where that's coming from. And now I multiply the numerator by the flip of the denominator, and I multiply straight across. 1 times 2 is 2. This is 2 radical 3. And I'm going to cancel 2's. And so I have 1 over radical. But I know I shouldn't have a radical in the denominator. So I take my answer over here where I have some more room, 1 over radical 3. I'm going to rationalize the denominator, meaning get rid of that radical. I multiply by radical 3 over radical 3. This is a 1, right? So it doesn't change the value of the fraction. It just changes the form of it. Multiply straight across. And I get 1 times radical 3 is radical 3. When you multiply a radical times itself, you get 3. So the code, now I shouldn't have boxed it in because that's just the tangent. What is tangent? The cotangent is going to be the flip of this. So for the cotangent, I've got to flip it. So that's going to be 3 over radical 3, which we have to rationalize again, multiply by radical 3 over radical 3, get 3 radical 3 over, and I would get radical 3 for the answer. So remember, this was just a long step because it's tangent, but this was the first one, evaluate the reciprocal. We had to do all that work to get to radical 3 over 3. That was step 1. This was step 2, flip it. Okay? Let's do the cosecant. If I'm doing the cosecant, I'm going to get a different color so you can see it better. I want to do the cosecant. I first evaluate step 1. Look at your unit circle. This is in quadrant 3. And the answer is negative radical 2 over 2. And it's just memorizing that unit circle. So that's step 1. Step 2 is flip it. So the cosecant of 5 pi equals negative 2 over radical 2. So gotta rationalize radical 2 over radical equals negative 2 radical 2 over 2 radical 2 times radical 2. And I can simplify 2's out of there and I get negative radical 2. So process, be very careful, all right, these on the bottom are for you to do. Let's do the cosecant of pi over 2. So the thing I will do is the sine. The sine of pi over 2 equals, go to your unit circle. You're looking, this is an x, a y. The sine of pi over 2 is 1. There it is, pi over 2, 1. Is 1. What is the cosecant? Well, it's flip. So the cosecant of pi over 2 equals, this is really, anything is really 1, right? So the cosecant is the flip, which is just 1. Let's do this cotangent of pi. So I'm going to evaluate the tangent. So I go back to my unit circle. Pi, here I am on the left. The tangent is the y over the x. So let's do that. We have 0 over negative 1 equals 0. But I didn't want the tangent, right? I wanted the cotangent. So I first evaluate the flip it. The cotangent of pi equals, flip this, because you flip that and you get 1 over 0. And you should have in your head, I can't later. Does not exist. So sometimes with tangent and cotangent, you're going to get exist. All right, go ahead and do the rest for your homework. Finish that up, and you can check your answers when you get to class.